Welcome to Pomodoro Joe for Monday, June 19th, 2023. Today we're doing LeetCode problem 1732. Find the highest altitude. This is an easy problem. There is a biker going on a road trip. The road trip consists of n+1 points of different altitudes. The biker starts his trip at point 0 with an altitude equal to 0. You are given an integer array gain of length n, where gain index I is the net gain in altitude between points I and I+1 for all I, which is 0 less than or equal to I, which is less than n. Return the highest altitude of a point. Okay, so this one seems pretty straightforward. So for this, we're not given the actual altitudes, we're given the difference in altitudes, so the delta. So we start at 0, then in this example here, we go down by 5. Then in the next point, we go up by 1. So at this point in our trip, we're actually down a net -4. Then we go up by 5, so we're at +1 at this point. So far, that's the maximum we've seen. Then we go 0, so we're still at +1, and then we go down by 7, and we end up at -6. So for this particular array, our max altitude was 1, and it looks like we do output 1. All right, then for this guy, we start at 0, we go down 4, we're at -4, then we go down 3 more, we're at -7, then we're at -9, -10, then we go up to -6, then we're at -3, and then we're at -1. So we actually didn't gain anything after our first initial 0, so we return 0. Okay, so this one seems pretty straightforward. For this one, we will be using a running sum. So we'll put 25 minutes on the Pomodoro timer, and we will get started. All right, so for this one, we do need our result, and I will start it at 0 because that's where we start the trip. And we will return the result when we're done. Okay, so we have our result. We're going to start it at 0. We'll return our result when we're done. Now we need to go through every single element in our gain. We'll also need to keep track of our running sum. So let's do that here. And we'll start that at 0 as well. So our running sum will just be the sum of all the elements that we've seen so far. Essentially, we're just keeping track of these deltas. So for every n in our gain, there are different ways to go through arrays in Python. We're just going to use the simple iteration, which is for every n, or every altitude, or delta, whatever you want to call this. We can call it delta. For every delta in gain, we will basically be adding that to our running sum. So our running sum, so we could say equals running sum plus this delta, or we can use the shorthand, which is just plus equals delta. So this is something that a lot of languages provide shortcuts for, because this is a very common thing to do. You take some value and you add some new value to that value and replace it. So this running sum will equal the running sum plus delta. So the shortcut we could use is, instead of saying the running sum is equal running sum plus delta, we say the running sum plus equals delta. So this knows that we're taking delta, we're adding it to running sum, and then we're replacing that value in running sum with this new sum. All right, so that is our running sum. Now our result. Our result, we are looking for the maximum altitude of our entire road trip. So we basically have to check every single time we update this running sum. Is this one the maximum? And for that, we will do result is equal to the max of our result, or this running sum. And then at the end, we return our result. So this max is just checking to see which one of these is the max value of the two, and it will assign that to our result. All right, so this should do it. Let's see how we do. And we pass. Let's see if we pass all the tests. And we pass all the tests. We don't do very well though. We only beat 16% for runtime and 26% for memory. So let's jump back here and see if we can speed this up a little bit. So a couple things we could do here. One thing, I can't decide if I should do a lot of changes now or just one change and then check again. Let's just do one change and check again. So this max, we could replace this with our own maximum calculation by saying this will be equal to result. Now this is a very Python way of doing it, so not every language will have this type of option. You might not be able to do this. So result will equal result if the result is already greater than our running sum. Otherwise, else, we'll replace it with running sum. So this is our own max type calculation. So the result will equal the result if the result is greater than running sum. So we won't change it if it's already greater than this running sum. Otherwise, we will replace our result with this running sum. All right, that's the only thing we'll change. Let's see if we do any better than our 16% for runtime. And we do a lot better. Now we're at 46% for runtime and 66% for memory. So that's a lot better than our, what was it, 16%? Yep, doing much better. All right, now there's not a ton of things that we can do here, but in Python, it does have to parse all of these strings when it basically runs through this program. So we can change some of the names to make this a little bit shorter. So like running sum. If we did call this delta, that might be a little bit better. We can call it total. I'll call it total here. Now this delta, let's just call it n, something simple. So for every n in, and let's see, this will be our total plus equals n. And then our result will be result if result is greater than our total, else total. All right, let's see if this is any faster. And it is. So now we're at 78% for runtime and 26% for memory. So we can keep doing things like that. So for example, we can call this just R for result and T for total. And we can actually assign them on the same line. So we can actually do something like this. So we have one line to parse instead of two. So R comma T equals 0 comma 0. And in gain, now we have to change that T, change this to R, change this to R, and these to T's, and this to an R. All right, and we can even get rid of spaces, so we have fewer things to parse. So you could do something like this. Let's see if it still works. I will say, however, if you're actually writing production code, this is not the best coding style. This is going to be difficult to read. People won't understand what does T mean, what does R mean. I wouldn't recommend this style of coding in general, but just to make some gains for this type of, puzzle, yeah, why not? And we do make a little bit of a gain, 83% for runtime and 66% for memory. So yeah, not too bad. And just to double check, I want to go back and switch this back to our max just to see. All right, let's see if this does any better than ours. And it doesn't. So it does pay to do your own max calculations sometimes. All right, we do way better in memory though. Wow, 91% for memory. That's pretty awesome. All right, well, that is it for me. We did a running sum, we kept track of our max result, and we returned the max at the end. That's pretty much it. I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.